Pneumatic cylinder is a linear actuator powered by compressed air to supply force on a load. The assembly shown here is the most common type of double-acting pneumatic actuator used in industries. It consists of a piston rod. This rod transfers force of compressed air to the load. Cushioning pistons are assembled with this rod. These pistons prevent any hard shocks at the end of the stroke by enabling the piston to stop slowly and gradually. The piston reciprocates back and forth when there is pressure difference between any of the two sides. A static seal ensures airtight sealing between the piston and rod. Piston guide rings are assembled to prevent metal-to-metal contact of piston and cylinder. Piston seal provides airtight sealing between the cylinder and piston. This whole assembly then goes into a cylindrical bore. This cylinder is generally made up of aluminium or steel. A cylinder cap encloses cylinder chamber in one end and the cylinder head encloses a chamber from the other end. Cushioning buffers and seals are installed on respective ends. Captive adjustable cushioning screws are installed on each end. These screws enable user to adjust the optimum cushioning at the end of the stroke. This whole assembly is held together with tie rods. These rods also provide compressive and tensile strength to the actuator. Air ports are screwed to the ends through which compressed gas flows in and out. A pneumatic valve is connected to these air ports using pneumatic hoses. The valve shown here is a 5-port 4-way valve. The ports A and B are connected to the cylinder. Port P is connected to the compressed air supply unit. Ports R and S are exhaust ports to which the pneumatic mufflers are attached. Now let's understand how a pneumatic cylinder works. The compressed air is supplied through inlet port P of the valve. The valve directs air to a particular direction, which we can observe in the animation. In this case, the air is directed to port A. This high pressure gas is then transferred to the cap end of cylinder through the pneumatic hose. This creates high pressure in the cap end of cylinder, which therefore pushes the piston towards the head end. This also pushes gas from the head end. This exhaust gas travels through the other hose and reaches the valve. The valve directs this gas towards port S and allows it to escape through a pneumatic muffler. The gas muffler helps to reduce any noise produced during exhaust. The process we just observed is the extension stroke of actuator. During the retraction stroke, the valve directs compressed air to the head end of cylinder. This causes the piston to return and air on the other chamber escapes from the exhaust port R. The theoretical force of actuator is the relative pressure on the piston multiplied by effective area of piston on which pressure is exerted. Here, the relative pressure is pressure of supplied air minus the atmospheric pressure. During extension stroke, compressed air can exert pressure on total cross-sectional area of piston. This gives us the expression of theoretical force as relative pressure multiplied by total area of piston. During retraction, the effective area of piston is reduced because the air cannot exert pressure on the area of rod. This gives us the expression of theoretical force as relative pressure multiplied by partial area of piston. Frictional losses on the interface of different surfaces also needs to be considered while designing pneumatic cylinder. The diameter of rod and length of stroke is also a determining factor for capacity of actuator.